Okay, welcome back. And this part, we're actually going to scatter these proxy rocks, proxy trees, proxy other trees. So we already made an example of our scattering technique here. Basically, by selecting all the terrain that we want to scatter on, and basically deleting what we don't want, and calculating the edge, the distance to the edge, and use that to remove and scale the points. So the only thing we really need to do, I say jokingly, is to actually put it in a for loop. Okay, there we go. So just Ctrl C, Ctrl V, and create a for loop. And in this case, we're going to use for each named primitive. Okay. I'm still in manual mode right now, so that's fine. And we're actually not going to put these right in the middle of the floor, because what we want to loop over is not actually the scattering itself, or you want to apply the scattering on every loop instance, but you want to loop over the scatter types. So we'll make one scatter type for the rocks, one for the pine trees, and one for the leaf trees, for the deciduous trees. And to do that, we're going to use, or pretty much reuse, a piece of code that we used in the first series of this tutorial. So I'm just going to copy paste that code from off screen. So for those who followed that part of the tutorial, it should be hopefully a bit more clear, but I added some comments in the code as well. I'm going to click here and use Alt E to make the window a bit larger. Okay. So let's go quickly over it again. This Python sub basically reads from a CSV file on disk and writes that to attributes. So for every column of the CSV that we give names, we create an array, and for every column we make read the cell and put that cell into another array, and then we use those secondary arrays to create the new attribute again. So when we're finished with that, we can pick from these attributes to actually do our math later. So there's just one small change that we need to make from the old code, and that is here, because in the previous version of this code we basically only have a string attribute in the first column, so column 0, but in this case we actually will have 3 columns with string attributes or string parameters. So that's the only real difference. Okay, so because I copied the code, right now it will probably generate an error. Yes. And what is the error? The error is non-type object has no attribute eval string, and that is in line 2. and that is because this parameter has not been specified yet. So let's do that. Go to edit parameter interface, add a string attribute, copy paste that, and do that. And let's actually put it on top. And we'll also use a reload button like we made last time. So how.pw to get the wd to get the current node dot cook and force the cook to be true. Yeah, true to force cook. Okay, and now there should no longer be any error. Okay, so let's actually create this scattering. I already saved to the right folder. So to check, we just put it in the root for now. Later we could move it if you want to. So what do we need to put in this seed? And we can put some more stuff into it later. But first let's add a scatter name, pretty much like the biome name. We'll add a instance, and this is where we'll specify what type of object to spawn. We'll add a scatter limiter. I'm actually using a small I instead of a capital because instance is a generic accepted attribute name in Houdini. So we'll just keep using that. Scatter density. And if we go back to here, we also want to have all these attributes as attributes, basically. So min biome edge dist max biome edge dist min scale min scale and max scale, and later on we'll add 2 more, but for now this is fine. So for our scatter names, we're going to use cliffs, trees, pine, and trees leaf. And now I need to quickly go here, yes. So right now we're in this folder. So if I go to geo and instances where we saved all our files, yes, we need to specify the instances in a way that is compatible with that. So what I'm going to do is add a character to replace the frame number. Instances inst. Well, I guess I should just copy paste it. There we go. So did I do that right? I think I did. Right. Yes. So we're there. /geo instances. Yes. Okay, that should work. I'm going to replace the 0 by the hash symbol, so we can in Python later or in Vex replace this number, this character by the number, so we can actually randomize which cliff to actually spawn. I'm going to do the same for the other thing. So 3 fine and 3 leaf. Okay. For the scatter limiter, going back to here. In this case, we actually say you can just literally copy paste this, or I think we could do that, I guess, as well. But we can also directly use some attributes that we have. So we could say for the trees, the slope needs to be smaller than 0.1, and elevation needs to be smaller than 200, and the elevation is to be larger than 100, because for the leaf trees I only want to smaller than 100, because pine trees generally grow in higher, taller climates than leaf trees and colder. So I'm just going to use that as a rule for now, but you can get very creative with this. And for cliffs, I'm actually going to use the biome name is cliffs, because we still should have the biome name cliffs as well. So yeah, if I go here, biome name, water body, open, included, cliffs. So yes, that is the same spelling. Okay. And for scatter density, for 1 second. I'm just going to put this as a default for now. That one, no, this one, yes. Control V. And for the minimum edge distance, I'm just going to put 1 everywhere. And then for the cliffs, I'm actually going to use a slightly smaller number than for the trees. I'm actually going to create quite large cliffs between 10 and 20. And for trees, I'm actually going to put them between 7 times and 9 times. Yes. Okay. So let's Control S this. Okay. We still have an error. Ah, yes. Okay. Because it can't find the file name. That makes sense. Actually, instead of a file string, I could use a file parameter. So we should get the drop-down menu again, and we can load the scattering CSV file. Okay, so now we should have some points in the middle. It's just like the table import, but you already have all the attributes assigned. Those are just literally taken from here. So if we view them here, yes, so we can see that the instance and the scatter limit and the scatter name which are 0, 1, 2, which is smaller than 3, in here, which are now string attributes, and the rest is float, are float attributes. There we go. So now we have something to loop over. So auto table import scattering. I'm just going to put this in there. This is going to be points. I'm going to say scatter name. Yes. I think I probably should be consistent. No, I don't need to be consistent in this case. Okay. So now we have a thing that loops 3 times. Gather 3, because we have 3 points. And what we're going to do is actually use some spare input links. So you already copy pasted this. Into the full screen that I can have. And I like this to be much more to the left. Yeah. Let's clean. Oh, not do that. Okay, so for open group, I'm going to add a spare input. For each begins scatter name. Okay, there it is. I'm just do dot dot slash this, and now it should generate this purple line. It's now directly linked to there, and that allows us to use the -1 to reference this node. So instead of just the expression here, I'm just going to use points of -1, which is this node, and then 0.0, because we're looping over these points, so there should only be 1 point. And I'm going to use scatter limiter. And that should be it. That's in case you don't add it in the this fee file. Yeah. So if you don't add a semicolon here, might as well just have a double 1 at the end. Okay. So now, yes, that excludes just the lower area in the valley. I'm guessing, yeah, so this is the rule for the trees, the leaf trees, the deciduous trees. I'm actually going to select these, hold A and drag down to align them. Yeah, so actually going to get rid of this one and rename this to scatter group and promote that to primitives. Get rid of that one. Okay. Yes. So now we can also copy paste it in there. Okay, there we go. So we already have this too. Don't need to change that. We don't need to change this. We do need to change this. So again, we'll just add a spare input like this to do that. And well, I guess I'll start adding it like that. And then we'll use points -1, 0.0, scatter density, and then the first value in that tuple, if it was a tuple. Let me double check. It should be this. There we go. So why is that not working? That type operation. Control X. Okay, so it has to do with this at least. Oh yeah, sorry, it needs to be point, not points, because in this case it's a float value and not a string value. Okay, and now we actually need to assign the instance as well. So we, oh yeah, and I guess we'll set the scale to, what is this? Oh, that's this one, okay, yeah. Set scale. And in this case, we don't need to use a spare input because we can directly just link it to the second input of the wrangle node. So let's edit the wait, Alt E. Yeah, there we go. Okay, so instead of using the CHF, we can just use point expressions. So I'm just going to copy paste all these. Oh wait, it's going to be a bit annoying, I think. Yeah. Just copy paste that there. And paste that there. So float going to be this min is going to be 0.1 because it's the second input. Going to be min biome edge dist, and it's going to be 0.0, and that's still fine. And then we'll add 3 more floats. Float dist max, float scale min, and float scale max. I'm just going to copy paste this. This is going to be max biome dist. This is going to be min scale. This is going to be max scale. Okay. So now we can just say dist min to this max is going to remap the value to scale min to scale max. Yes, that should do it. Okay, oh yeah, of course. There we go. So now we should have p-scale values, yeah, between 7 and 9. Seems to be true. Yeah, great. Okay, and now we just need to assign the instance name as well. So for this, I'm going to use another Python sub. Yes, okay. Because what we're going to do in this Python sub is actually look in this folder and check for every name how many files there are in this list to check how we should do the randomness of the file selection. So for this code, we'll need import string and OS. I'm going to do again my path is geo dot yes, of course. So we can actually use directly the instance name of the point, which comes from here. We're going to use this attribute. So we're going to fetch the points from the geometry, and we're going to fetch the first point because there should only be one point. And then we'll ask for the string attrib value of instance. Okay. If I print path, that should actually print the name, which is what we want. Okay. So right now we have the instance, but we also want to actually get the path. So because right now it's saved as $hip, we actually want to get the full path. And there is something in the OS library to do that. So is string dot template my path dot substitute os dot environ. I will add some comments in the code where you can find the documentation that I used to write this code. So now, yeah, we get the full path. Great. Okay, so we're just going to do now is actually go get the path. I'm going to do that in the lazy way, or which should be good enough in this case. I'm going to find the last slash, and that is my path dot r find to search backwards in the string. Okay, and then file name is going to be my path, and then use some Python slicing of last slash plus 1 till the end. Oh. Okay, so it's file name. Okay, that doesn't work. Did I forget something? What's the problem? Last slash. Ah, there we go. Okay, yes. So now we actually do get it. Great. Okay. So we can now use file start. It's file name from the start till we find the hash character. So print start. Okay, so now we get that. And now we're going to create an array of all the files that start with this name in this folder. So only files is file, it's going to be an array, file for file in os.list here, my path, if os.path is file, os.path join my path dot comma f, and f dot starts with file start. I think that's, cannot find the path specified. Yes, that makes sense. Okay, let's do this in smaller steps. Okay, so I'm just going to comment that out. Okay. Wait. So cannot find the path. Yes, of course. So I need to actually, since we have the file name, we also need to remove the end of the string. So my path from the start till the last slash index. There we go. Okay. So for all the files in that directory, I'm going to check if that file or that string is actually a file, and if it starts with the file start. Okay, that still works. And now I'm going to print only files. And yeah, for tree leaf, there should only be one. So that works. Which is tree leaf one. There we go. And I'm going to see if I can actually do this. Okay, it's going to error out. So if I do single pass, yeah, so now the pass 0 is going to be the rocks, and it will enumerate all the rocks. Okay. So we need to do now. Okay, let's do that. So I'm going to count the files that we have found. So n files is len of only files. And if there's more than one, we're going to add some extra points. Or if it's bigger than 0, I would say. Yeah. Because otherwise we don't really care about this part of code. We'll add some dummy positions, much like what we do here at the end. Yeah, so we create like some dummy positions to generate our data on. So dummy positions is a tuple array 0, 0, and that is going to be as long as n files minus 1. And we're going to create geo.create points using these dummy positions. And actually I'm just using -1 here, because if the point itself, I can also just overwrite and use that. Otherwise we'll have an extra point which will be inconvenient later. That's just going to overwrite the input point and add any additional points that are required. So let's get all points again. And for all the points, range 0 dot len points into points I dot set attrib value instance. So we're just going to override the instance attribute my path plus slash plus only files, and then the index that it's currently in. Okay, so did that work? Not, oh wait, I'm in manual mode. That would be why. Let's click on something else, click on this again. Yes. Okay, so now we have the full path. This is just the rocks. Yeah, this one thing I don't really like about Houdini. Yeah. But yeah, you can see that there are 13 rocks here. So 1 to 12 plus 0. And we have the same here. if I would can I maybe if I make it bigger like this, it might work. Yeah, okay. So now you can see that we actually have all the rocks with the hashtag or hash character replaced with the number. Okay, great. So this is going to be create points per available file. And now we just need to assign. So I'm just going to do this again. Put that there. Put that there. Make it a bit nicer. Because like the lines to be 90-degree angles if I can. Well, it's close enough. Okay, so assign instance file. So here, what we're going to do is we're going to count the variations, which is equal to the number of points in the second input. Going to get an index, which is going to be an integer, and that's going to be the rounded value of rand ptnum times the amount of variations minus 1. There we go. And then instance is going to be point from the second input instance, and then we're going to fetch it from the point that we chose. So chosen index. So basically this just picks a random point from this geometry and use that to assign the instance attribute. Okay. So why don't we have any expression? Okay. So okay. That's slightly problematic. How did I solve that? In my example. Oh, I'm using the wrong quotes apparently. So if I would save as Terrain, yes, that doesn't ask me. Okay. Terrain B. That's not actually asking me. This is maybe when I'm creating it. New spreadsheet. Save as CSV. Terrain with C. Yes, keep current format. There we go. So the field delimiter should be semicolon and the text delimiter. Yeah, that's the right one. Okay. So what I'm going to do is just copy paste that and replace those. I'm going to save it again as and save of the original. Now I'm going to use our label, call it reload. And let's press it. And now we should hopefully, I guess, do that. Yeah, there we go. So now it's actually the right code. So we have our cliff area. We make it a primitive group. Remove everything that's not in the group. Scatter on it. Wait, why? That's not working. Oh wait, sorry, that's not scatter. Scatter is here. There we go. And we set scale. Okay. And now at the output of this, we should have for the instance, go again, this back. Yeah, so now we have all the random rocks that we want. And if I would disable single pass, let's take that longer. Now I'm just going to sort by instance, and now we should have tree spine, tree sleeve, and rock cliffs. Perfect. Okay, so in the next part of this tutorial, we're actually going to place the instances, and we'll add some extra attributes onto the instances to make it fit better into the terrain. So hopefully see you there.